And here we go. So, for starters, the objective today, we're solving the rational equations. So we've been working with the expressions, we've been finding the common denominator, correct? And then we've been combining those as we see necessary. She's not here. That was last period. Sorry. So, the objective today, we are going to solve equations containing rational expressions, and I'll show you exactly how to do it. This kind of goes into a little bit of detail on how you do that, but I'm going to show you what we're going to do with that. So, solving rational equations, you should already have this written down. The first thing that we need to do is find a LCD, that common denominator, right? And that's what we've been doing, so we should be good at it. We started that with section 8.1. Now, this is just one number. That is one number. This can be factored because it is a difference of squares into x plus 3 and x minus 3. Okay? So, when I want to find the LCD, I'll make a little note, and I'll use another color too. My LCD would have to be, I need x minus 3, don't I? And x plus 3? So, do I need to put this one in there? No, it's already taken care of. Do I need to add this one? No, it's already taken care of. They're both there already. So my LCD is x plus 3, x minus 3. Thumbs up, thumbs down. We're good, we're not good. A little confused. Show me, show me, show me. Down. All right, cool. So, that's the hard part. That's the hard part. No, Mr. Munoz, you always say that. I'm going to multiply every one of these terms, this guy, and this guy, by that LCD. Okay? It's going to look like this. X, what I use, green? X times x plus 3, x minus 3, and that is over x minus 3, right? And I'm going to add to that x plus 3, x minus 3, and that is over x plus 3. I should put these in parentheses. And that's going to equal, equal to, I've got x plus 3 in the denominator, and x minus 3. And of course, x plus 3, x minus 3. Okay, I just want to make sure everyone's okay with what I did here. Everything got multiplied by the LCD. Go ahead.
Why didn't the denominator change if that's what you were finding?
Yeah, it was x, it was this, right? And then I factored into this. So I just left it in the factored form.
Yeah, but for the LCD, wouldn't you change the first two too, or no?
Well, what is the LCD? It's x plus 3, x minus 3, right? Yeah, so here I'm solving. So notice the black part is the original equation. That's why I did two tones here, two colors. If you take a look at the black part, it's the original equation. And all I did was to multiply every one of those terms by the LCD, which is in green. Do you see it? Examine that for a second. Make sure you know what you're seeing there.
Wait, why are you doing the actual answer?
I'm doing to everything. Because remember, the rule says whatever you do to one side, you got to do to the other, don't you? So I just multiplied the entire left side by x plus 3, x minus 3. I got to make sure I do it on the right side as well. Now, Mr. Munoz, looks like you just made that harder, right? And actually, we did it because, remember we keep saying anything over itself is 1. So look what happens. That's a 1. That's a 1. That's a 1, and that's a 1. What happened to all my denominators? Gone! There's no more denominators. Now, up here at the beginning, I've got x and x plus 3 left over, correct? So that becomes x squared plus 3x, correct? You guys cool with that? Over here, I've got the x and the x minus 3 left over, which is going to give me, let's see here, x times x is a positive x squared, and that's going to give me a negative 3x, correct? And that equals 2. Yeah. Oh, JK, thanks. Good looking out. That should be that. So look at this now. Beautiful. Now it's just, I shouldn't say linear, but I don't have rational expressions anymore. What should I do? What's your instinct here? What should I do at this point? Before I even solve it, because that's the process, right? What should I do? Yeah, do some combining, right? So let's see here. This x squared and this x squared gives me 2x squares. This and this, oh, I've been dying to use it. They cancel out. No air quotes. They're gone. That makes 0. What's that equal? 2. And I'm going to divide both sides by 2. That will give me, I'll make a little arrow here. That will give me x squared is equal to 1. How do I get rid of a square? Square root. So that means that x is equal to positive 1 and negative 1. Math. Not so bad, y'all. Not so bad, y'all. Man, that weekend was that bad? You guys are so quiet, so dead. Here, you try this one now. We'll keep it simple. Give you guys 5 minutes?
6.
3? 2? We'll do 3. Hey, what happened to my 3 minutes? I thought I had 3 minutes. Oh, there it is. We'll do a 3, and if you need 2 more, then we'll give you 2 more. Guys, just a tip, thank you. Don't factor the tops until you need to. Until you absolutely have to. Okay? Don't factor the top until you absolutely have to do it.
Okay. Well, no.
It's usually the denominators, right? That we're trying to get a common denominator. I need to take that. Actually, I think, yeah, this one I got now. These I got, these two I got from eBay. I think I got the 5 ones. And the 2s were. These were, when I got them, they were 25 euros. Yeah, they're worth it. No, move everything that way. Everything to one side. Well, I had the, like, there's a model under this one that said the 1,000 or 500 instead of mine. Because they're like, what, $6? But the clip would pop off. So when I put them on here, I would use that. Because they pop off. And I put, $5, $6. And it happens often. I said, you know what, I'll just buy this. This doesn't come off. I've had these for like 3 or 4 years, so they're $800 old. So it might be $25 is a lot, but for a teacher that has a lot of time on it, I think it's worth it. Man. That's Mira, I'm going to show you what to do. I like what you did, pero lo hiciste más difícil de lo que vas a tener que hacer. A little too hard headed. So, let's go ahead and get started here. Anybody got a solution they want to offer up? Try to call somebody? What do you got, Sylvia?
X squared plus x minus 4.
Solution, x equals. What does x equal? You got something?
Yeah, I got -3.
-3 and
That's it.
that's it?
Yeah.
So I got x equals -3 2 times. Can I get a third on that? All right, well, what's my LCD? X plus 2 is obviously my LCD. I'm going to multiply both sides by x plus 2. Because check out what happens. Pop, pop. So I end up with x minus 1 is x squared plus 2x minus 3. So I've got this. I want to make sure I get everything to one side. So I'm going to, what am I going to do? I have the habit of moving everything to the left side. But in this case, it's better to move everything to the right side. Because if you move this guy right here, it's going to be negative on the left. And I really don't want to factor with a negative there. Okay? So I'm going to subtract x and add 1. Subtract x and add 1. That's gone, that's gone. So 0 is equal to x squared plus x minus 2. At this point, I've got a quadratic that I can factor. So I should get a positive 2 and a negative 1. You see that? That means, in order for this statement to be true, x, in this case, would have to be a negative 2. And over in this case, x would have to be a 1. Correct? Questions here? Yes, I saw a lot of that. It's good stuff. But I'd have to take another look at it, see if we can get to that end point. Let's see, because I think it's exactly what I saw behind. This piece? No,
Yeah.
not this piece?
So factored this out, and then I divided the x minus 1.
All right, give me a second. I want to try something else real quick. You guys got this copied? Let me do the full screen. Because while you're copying that, I want you to think about something real quick. Are there restrictions on this equation?
-2. I should have got -2.
You should have got -2?
Yeah, but I don't know how to get the 1.
Okay. We'll do that in a second. Does this function, or yeah, negative 2. What did we get for solutions? We got 1 and negative 2. So what does that tell me? You can't have negative 2. That means that this one is a no-no. Because what happens if I put negative 2 in here? It adds up to 0. That's actually discontinuity, which would show up as an asymptote. Or undefined, technically, right? So I can't have it be that. That make sense? Same thing on the other side. If I put the negative 2 in there, that becomes 0, undefined. So the only solution we really got was the 1. Okay? Now I want to try some of the things that you guys were doing, see if we can get to that. Because you did the radicals, huh? Oh, was yours present? I'm looking, yes. So you see, I want to see what they did. Everyone good with this? Can I get rid of this now? No, not yet? Okay. I just want to try some other stuff.
Did you hear that Rubio's closed?
No, we didn't.
Really?
Closed yesterday.
Nah. What?
Yeah, I heard that too.
No sales? Like going out of business? Half off tacos? We can't keep anything, I tell you.
Yeah, because everything's in the valley. And everyone's they need to make Casa Grande more.
Well, hopefully when they what is it, the Phoenix Mart?
That thing's still happening.
Yeah, they already got rid of. From what I hear, they already opened up the area. So.
Well, I mean, I've driven out there, and it's like they have the sign, but they have like the building thing, but it's been a while, so.
It's taken a long time. But the idea is that when that opens up, that's going to bring in a lot of jobs, which means it's going to bring a lot of people. So we'll have a lot more people to invest in businesses and stuff. Maybe they'll bring back Target. That's all I want. Just keep Target here. You can even have Walmart back. Nah. I just hate going to Walmart.
Yeah,
I don't.
I like Target better.
I told my wife I'll drive you to the valley to go to Target if we don't have to go to Walmart. She's like, no, it's closer. It's a school night. Why? All right, here's what I'm gonna do. I'm gonna copy this, put to a new slide. Because I want to see some of the stuff that some people did. Obviously, you'll see that these denominators are going away. So we had, what did this factor to? What did you factor this to? X plus 1? Plus 1 minus 3?
No, plus 3 minus 1.
Plus 3 minus 1. Okay. So plus 3 minus 1. You divided both sides by x minus 1. So that's this. That becomes 1 is equal to x plus 3. Correct? So once we once we subtract 3, that means x is negative 2.
So then how do you get the 1? You just take from the denominator?
Yeah, see, that's the problem is with the 1 there. Because you had it, you removed it.
So we're just getting the discontinuity.
What you got ended up with was the non-removable discontinuity. Nope, no, I take that back. Because 1 was non-removable, right? Yeah.
No, 1 was removed. 1 is removed because we got
In the way you did it, yeah, it was removable. So that's why it didn't show up.
That's done. Can't do different ways to get the same answer.
Let's see here. I'm trying to think of. I'm gonna have to think about that one. Okay. All right. Try it again. Here you go, guys. Are you crazy? Oh, sorry, I was reading one of Mr. Shapiro's emails. You guys good? 40 seconds. Keep going. I'm not timing it. It's just. That's what I'm thinking about. I'm gonna go look because I had oatmeal this morning and oatmeal's not breakfast. Well, we have the rolled oats.
You like the steel?
I like the steel cut. That one fills you up.
I have a big chili burrito outside in my fridge, and I would think about it all. But I know when I get home it's gonna be gone, so I'm gonna try to
Pork and chili burrito. How I missed you. Oh. Are we good? Do we need some more time? All right then. Let me call some peeps. Is it me or does it feel like the internet just gets slower and slower every day? That's not even our class. I forget to switch it. There we go.
Our class is so much smaller.
Yeah, you guys are 23. Oh, she's gone. There's less people than what's on here. Yeah. Jesus. Good so. What did you get for an LCD? What did you get for a denominator? Like the common denominator. All right, what did you get factoring this denominator? You got x plus 2 and... Good job. Good job. You got x plus 2 and x plus 1. So what's my common denominator then? The LCD is going to be x plus 2 and with x plus 1, right? So I need both of those in there. Now, no, you need both of them. Now you guys can see what's going to happen, right? Some of that stuff is going to cancel out. So if you don't mind, I'm going to take a shortcut here. Starting with the first part of it right here, this x minus 1 is going to end up getting multiplied by what? Nothing. Because remember, these two are going to cancel out with the 2 that we multiplied by, right? So it just stays by itself. In the second part, the 2x will be multiplied by the x plus 1. Because the x plus 2's will make a 1. They'll simplify to 1. That's going to equal x minus 1 times the x plus 2. Correct. Because the x plus 1's will simplify to a 1 as well. So you end up with that. Are you seeing it? No, because that's a minus 1. The other one's a plus 1. They have to be the same.
Is this after you cancel out? Like,
This is what ends up after you cancel everything out.
oh, okay.
And I'm throwing up air quotes because a bunch of 1s, right? All right, cool. So all we got to do is clean it up. We're just going to clean it up, okay? Now, this is quadratic, so we want to make sure we end up with a quadratic that we factor at the end. Okay? So, I'm going to use blue. I'll start from the left side. This is x minus 1 plus 2x squared plus 2x equals x squared plus x minus 2.
Why would it be plus it?
Because this is 2x, and this is a negative x, right? So 2x's take 1x away, leaves you with 1 positive x. Okay? All right, let's clean this up a little bit. Let's start with the 2x here. That's just 2x squared. X, and those x will give me 3 x's. And then the minus 1. And then I've got x squared plus x minus 2. Like I said before, I like to move everything to the left, unless it's going to end up being negative for some reason. In this case, it's not. So minus x squared minus x plus 2. All of these will cancel out, and I'll end up with 1x squared plus 2x plus 1 is equal to 0. So I've got my quadratic that I need to factor, and, oh, that's an easy one. That's going to factor to plus 1, which means that x is equal to negative 1. Now I'll give you guys a little bit to process that and see if everything's hunky-dory. Can I say that, hunky-dory? Everybody knows what hunky-dory is? No? Hey, you okay? What's up?
Wouldn't negative 1 create discontinuity?
What did you say? One more time?
Negative 1 would create discontinuity.
If I use negative 1, how would that create discontinuity?
Wait, where are you getting
The answer, that's what we got as a solution for x. Yeah. If I took that negative 1 and I plugged it in right there, that would create discontinuity. And if I plugged it in right here, it would create discontinuity. Therefore, what is my solution? There isn't one. This has no solution. This has no solutions because negative 1 does not work. It would create, not discontinuity, well, yeah, I guess we could call it discontinuity, but it would have, it would become undefined, aka asymptote discontinuity. Nice job. Yeah. I need an air cannon.
No.
I'm gonna see if I can order one.
It'd be fun.
No.
Yeah, because then I can just blast people. Pop. I'm looking for one right now.
I would get so mad at you.
I bet you're talking about an air horn.
Yes.
No, not an air horn.
Not like hitting people with stuff.
No,
that's
you hit people with air.
not-
Have you not seen air cannons?
No.
It's like this
Oh,
huge
so
thing,
you go-
and then you just bop
Oh,
it.
to put on like flat tires.
No.
People get like cups hit off of them with those things.
Yeah, it's just like this huge cone-looking thing, and in the back there's like it's kind of like a drum, and it's open on the bottom. So when you hit it, all that air focuses into the vertex of the cone and shoots it in that direction. Oh man! Awesome!
That's how you get air by your purchase.
Yes. Dude, and they're only like $18. I'm getting one. We need exactly that. You feeling all right, Nico? You smelling that dust? Oh, sorry. I confused my new tunes with Davin, my tuna peeps. Sorry, Dav. Shauna. Shauna. No. Wakey, wakey. I thought you were checking if you had put on cologne perfume in there. But,
I did.
man, Monday's bad for you guys. Alright, so how you guys feeling about this? It's kind of not so bad, right? Because we did all the factoring, we did all the LCD type stuff, right, Mac? So it's just a matter of finding the changing the numerator as well. Now, that's the easiest way that I can show you how to do it algebraically. There's an even easier way to do it. Show me, Mr. Munoz, show me! Yeah! We're going to use the geometry method, which is graphing using our graphing utilities. So, that is the next thing. The last thing I have to do is show you how to solve these with rational expressions or rational equations using a graphing utility. So, I want to point this out real quick. We've done it before, but I just want to remind you. There are two parts of this equation, correct? What we're looking for is when the right side is equal to the left side. So the left side is the same thing as the right side. In essence, what I have here are two different equations. I have the equation that represents the left, and I have an equation that represents the right. So what I'm going to do is I'm going to throw those into my calculator, and it's going to look like this right here. There's my top one, and there's my bottom one. So I've thrown both of those into my calculator. You guys can try that in a minute. You guys okay with how I typed it in? Ooh, my ear's ringing. Ooh, that's hurting. Goodbye, hearing. You guys know that? Did I tell you guys that? Like, you ever hear it ringing in your ear? And just kind of there? And all of a sudden it fades? Oh, it doesn't mean someone's talking about you. It means that, like, that tone is the last time you'll ever hear that tone. Yeah, so when your ear's ringing, it rings at a certain frequency. And it kind of dies out.
Oh, are you serious?
Yeah, that's your hearing dying.
Oh, that's nice.
So that is the last time you will ever hear that frequency. Bye. Soon I'll be coming to school with a bullhorn. Where's your face, honey? Hey, one more time, please. All right, so anyways, I plugged in the left side, I plugged in the right side. I'm going to go ahead and graph those, and it looks like this. The top, the blue one, is the funky part, the left side. And the red line is when it equals 1. What am I looking for?
Right.
Yes, where the two are equal. In a graph, that means where the two lines cross each other. And there's only one time when they cross, and that's right here. Do you see it? When x is 0 and y is 1. Now, if you can't see it because there's no numbers there, I'm going to use this feature right up here where it says calculate. So you're going to go second, calculate, and I want to find an intersection, which is number 5. And it's going to say, what's the first curve? Well, the first curve is the whole left side up there. And the other curve is the right side, which is the equals 1 part. So I hit that. It says, hey, take a guess. Where could it be? Where could it be? Right there. Press enter. It's going to say, oh, the intersection is at 0, 1. Which means that our solution is 1. Our solution is 1. And that's it.
So would it be y equals 1 or x equals 1?
No, it's just 1. So, let's see here. Oh, that's a 2. Whoa, what? Oh, 0. 0. Sorry, what did we say x was?
1.
Yeah, the coordinate was 0, 1, right? Sorry about that. So 2 over 0 plus 2 plus 0 over 0 minus 2. This is all gone because that's nothing, right? And this is going to be 1. 1 does equal 1. So when x is 0, the function is equal to 1. Sorry about that. Questions? Not so bad, y'all.
So 1 is y.
1 is y. Yes. I don't know what I said. But x is 0, y is 1. So this is saying when we make x 1, our solution will be, sorry, I did it again. When x is 0, y would be 1. And that's what we were looking for, wasn't it? When, whoa, where'd it go? When this function equals 1.